Hello, in this lecture I will answer two questions. In the first question we find out the right edge of this lateral ABC, and in the second question we find out the area of this curve ABCD, and we also have to find out the length of this tangent PQ. So we start with the first question. In the drawing we have a circle that is described by this right angle ABC. This is a right angle. We know that BC equals to 40 units in its length. The radius of this circle equals to 4 units. Here our test is to find out the length of side A and B. This is the height of this right angle ABC. So first of all, we will define the relevant point to this question with letters. We define the center of this again. This point is point O. We define the point of tendency of tangent AB with this circle. This point is point D. We define the point of tendency of tangent BC with this circle. This point is point E. We define the point of tendency of tangent AC with this circle. This point is point F. In the next step, we will join points O and E together by a straight line. Point O is the center of this circle, point E is the point of the circle itself, therefore OE is the radius of this circle. That equals to 4 units in itself according to what is given as the question. The radius OE that equals to 4, the radius OE is known to point E, that is the point of tendency of tangent BC with this circle. Remember, your radius that is known to the point of tendency, then tangent BC will be perpendicular to the radius EO. If BC is perpendicular to EO, it means that this circle equals to 90 degrees inside. This circle also equals to 90 degrees inside according to rule 1. Likewise, we join points O and D together by a straight line. OD is of course the radius of this circle. This is equals to 4. The radius of D is equals to 4. The radius of D is known to point D. This is the point of tendency of tangent AB with this circle. Remember, your radius of D is known to the point of tendency, then tangent AB will be perpendicular to the radius DO. If AB is perpendicular to DO, it means that this circle equals to 90 degrees. Next side, this circle also equals to 90 degrees inside according to the same rule 1. So in total, inside this small quadrilateral ODBE, we have 2 fair angles. The sum of fair angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle. In total, it must be equal to 360 degrees according to the rule that said that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside the small quadrilateral DOEB we have 4 angles. Therefore, we can relate to this quadrilateral DOEB as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in the small rectangle DOEB, side DO must be equal to the opposite side BE. But DO is 4, therefore the opposite side BE must be also equal to 4 units in its length. Likewise, according to the same rule, in the same small rectangle DOEB, side OE must be equal to the opposite side DB. But OE is 4, therefore the opposite side DB must be also equal to 4 units. The opposite side DB must be also equal to 4 units in its length. So in total, if you want the square for diagonal ODBE is not the rectangle but the square. One equals all of its sides are equal to each other, its side equals to 4. So it is not. So diagonal DOEB is a square. What is the length of this missing 9797 AC? From the drawing, it is very easy to see that EC in total equals to BC minus VE. So write it down. EC equals to BC minus VE. So EC in total equals to BC is 40 units in itself, according to what is given in the question. Minus BE, B equals to 4. So in total is equals to 40 minus 4, that is 36. EC equals to 36 units in its length. EC equals to 36 units. Here we can implement all two in our drawing. I can click on all two. According to rule 2, the lengths of two tangents from a common standpoint to a circle are equal. In the drawing, we have a circle. This is a common standpoint, point P. From this common standpoint, point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule 2, they are equal to each other. That is to say, PA equals to PB. So we can actually implement rule 2 in our drawing. What is our drawing? If we focus at this common standpoint, point C, from this common standpoint, point C, we have two tangents to this circle, tangent CE and tangent CF. And according to rule 2, they are equal to each other. That is to say, CE equals to CF. But we already found out that CE equals to 36, therefore we already found out that CE equals to 36, therefore CF must be also equal to 36 units in its length. In the next step, we focus on this common standpoint, point A. From this common standpoint, point A, we have two tangents to this circle, tangent AD and tangent AF. According to rule 2, they are equal to each other. That is to say, AD equals to AF. So if we define the length of tangent AD as x, then the length of tangent AF must be also equal to x. In the next step, we will implement the Padua theorem on this big right angle, triangle ABC. According to the Padua theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle ABC, here by PT is a motion for Padua's theorem. So in the right triangle ABC, according to the Padua's theorem, the following equation is true. AC squared, that is the square of the hypotenuse, equals to AB squared plus BC squared. Again, according to the Padua's theorem, this right triangle ABC, the following equation is true. AC squared, that is the square of the hypotenuse, equals to AB squared plus BC squared. AC in total equals to x plus 36, therefore AC squared is x plus 36 squared. And is equals to AB squared. AB in totality is x plus 4, therefore AB squared is x plus 4 squared. Plus BC squared. BC equals to 40, therefore BC squared is 40 squared, that is 1600. So in total, if you know that x plus 36 squared equals to x plus 4 squared plus 1600. Here we'll open the brackets on both sides of this equation and we get that x plus 36 squared equals to x squared plus 36 squared. 36 squared equals to 1296 plus 2 times x times 36. 2 times x is 2x and 2x times 36 is 72x. And it equals to x plus 4 squared. X plus 4 squared equals to x squared plus 4 squared, that is 16, plus 2 times x times 4, that is 8x, plus 1600. Here we have x squared on both sides of the equation, so x squared is cancelled. After I cancel x squared in the side of the equation, we left only if 1296 plus 72x, and is equals to, on the other side of the equation we have 16 plus 1600 is 1616 plus 8x. So here we subtract 8x from this equation. So here at x will get cancelled and we left only with 1616. While on the other side of the equation we left with 72x minus 8x is 64x plus 1296. So in total, if you know that 1296 plus 64x equals to 1616. Here we subtract 1296 from this equation. So here 1296 will get cancelled and we have only 64x equals to 1616 minus 1296 equals to 320. So if you found out that 64x equals to 320, here we divide this equation by 64 and we get that 64x over 64 is x equals to 320 over 64 is 5. So in total, if you know that x equals to 5 units in its name. Our test is to find out the length of this side AB is equals to edge. The right edge of the right triangle ABC is equals to AB equals to AB in total equals to AD plus DB. AD is x plus DB is 4. But x equals to 5, so can I write down that AD is equals to AB equals to x, that is 5 plus 4. 5 plus 4 is 9. So in total, if you want to know that x, the right edge is equals to AB is equal to 9 units in its name. Again, in total, if you want to know that the right edge of this triangle ABC is actually equals to AB is equal to 9 units in its name. So we finished to answer the first question. The next step, I present you the second question of this lecture. And answer the second question. In the second question, we have two tasks. The first task is to find out the area of this square ABCD. The second task is to find out the length of this tangent QP. So in the drawing, we have a quarter circle and a semicircle inside this square ABCD. This is tangent PQ, that is tangent to both the semicircle and the quarter circle at this point. So we define the point of tendency of tangent PQ with the semicircle and the quarter circle. This point is point K. We also know that the radius of this, according to what is given as the equation, the radius of this semicircle equals to 17 units in its length. Likewise, the radius of this quarter circle equals to 46 units in its length. So in the next step, we define the relevant points of this question with letters. That is to say, we define the center of this circle. This point is point O. We define this point as point Z. We define the short isomorph ZB as X. We define this point as point L. And we define the length of this short isomorph BL as Y. DL is the radius of this quarter circle that equals to 36 units in its length. So the first task is to find out the area of this square ABCD. So what is the area of this square ABCD? Actually, we know that the area of any square equals to the length of one side squared. So we choose the side of this square ABCD as AB, so it is AB squared. AB equals to OZ is 17, this is the radius of the semicircle. The diameter of the semicircle is 17 plus 17 is 34 plus x. So AB in total equals to 34 plus x. And therefore AB square must be equal to 34 plus x squared. So if you found out that the area of square ABCD according to the first method of calculation, is equal to 34 plus x squared. They are the same square ABCD according to the second method of calculation. Equals to the length of side BD squared. BD in total equals to y plus 36. Therefore, BD squared must be equal to y plus 36 squared. So in total, according to the second method of calculation, the area of the same squares ABCD is equal to y plus 36 squared. So we have two different equations for the area of square ABCD. Equation 1 and equation 2. Therefore, we get equation 3. It states that the area of square ABCD according to the first method of calculation must be equal to the area of the same square ABCD according to the second method of calculation. Very simple equation. So the area of square ABCD according to the first method of calculation equals to 34 plus x squared, and it must be equal to the area of the same square ABCD according to the second method of calculation. The area of square ABCD according to the second method of calculation equals to y plus 36 squared. So according to equation 3, we found out that 34 plus x squared equals to y plus 36 squared. Here we take a root out of this equation and get that. So in this side of equation 3, the root cancels the square and you left only 34 plus x. But on the other side of the equation, the root also cancels the square and you left only with y plus 36. So we found out that 34 plus x equals to y plus 36. Here we subtract 34 from this equation, equation 3. We get it according to equation 3. Here 34 will get cancelled and left only with x. And on the other side of this equation 3 we have 36 minus 34 is 2. So we left only with y plus 2. So total we found out that x equals to y plus 2. According to equation 3, we found out that x equals to y plus 2. Here we can implement rule 10 in our drawing. Because again, we can implement rule 10 in our drawing because we have an external between the semicircle and the quarter circle at point K. And whenever you have an external between two circles or semicircles, you can implement rule 10. So I pick quickly rule 10. According to rule 10, if two circles touch each other externally, then the straight line that connects the circles together passes through their touching point. So in the drawing, we have those two circles that touch each other externally, it's point P. The center of this circle is at point O. The center of this circle is at point M. The straight line that connects the circles together is of course the straight line OM. According to this rule 10, the straight line OM must pass for their touching point, that is point P. Or the straight line OM must pass for point P, that is their touching point. Or OPM is one straight line. Again, OPM is one straight line according to this rule 10. So if OPM is one straight line, it means that OM in total must be equal to OP plus PM. So we can actually implement rule 10 in our drawing. In our drawing, the 7 second touches the quarter second, accelerates point K. Therefore, we can implement rule 10. The center of this 7 second is at point O. The center of this quarter second is at point D. The straight line that connects the centers together is of course the straight line OD. According to rule 10, the straight line OD must pass for point K, that is the touching point. Again, the straight line OD must pass for the touching point, that is point K. Or OKD is one straight line. Again, OKD is one straight line according to rule 10. So we join points O and K, O and D together by straight line, and according to rule 10, the straight line OD must pass for point K, that is the touching point. So from the drawing it is very clear that the straight line OD passes for point K, that is the touching point, exactly according to rule 10. And according to rule 10, OD in total must be equal to OK plus KD. So OD equals to OK. And again, according to rule 10, OD in total must be equal to OK plus KD. Why? Because OKD is one straight line. So OD in total equals to OK. OK is the radius of this semicircle. That equals to 17 plus KD. KD is the radius of this quarter circle. That equals to 36. So in total, we found out that OD equals to 17 plus 36. 17 plus 36 is 53. So OD equals to 53, it's in its length. So I did now. This is the straight line OD. This equals to 53 units in its length. ABCD is a square, therefore this is a right angle. In the next step, we will implement the Pythagoras theorem on this green right triangle OBD. And again, we implement the Pythagoras theorem on this green right triangle OBD. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right green triangle OBD, here by PT is the equation for Pythagoras theorem. So in the right triangle OBD, according to the Pythagoras theorem, OD squared, that is the square of the hypotenuse, must be equal to OB square plus BD square. OD, the hypotenuse OD equals to 53, therefore OD square equals to 53 square. 53 square equals to 2,809. So OD square equals to 2,809, and it equals to OB square. OB in total equals to 17 plus x, therefore b squared is 17 plus x squared. Plus bd squared. bd equals to y plus 36. And again, bd equals to y plus 36, therefore bd squared equals to y plus 36 squared. So in total, we know that 2809 equals to 17 plus x squared plus y plus 36 squared. Here we'll open the brackets on this side of this equation and get that 2809 equals to 17 plus x squared. We already found out that x equals to y plus 2. So x equals to y plus 2. We can substitute here x by y plus 2. So 17 plus x is 17 plus 2 plus y. 17 plus 2 plus y equals to 17 plus 2 is 19. So this expression equals to 19 plus y. Thus we substitute x by y plus 2. So 17 plus x is 19 plus y squared. So total we know that 17 plus x squared equals to 19 plus y squared. And also here we have also y plus 36 squared. So in total we found out that 2809 equals to 19 plus y squared plus y plus 36 squared. Here we'll open the brackets on both on this side of this equation and get that 2809 equals to 19 plus y squared. 19 plus y squared equals to 19 squared is actually 361 plus y squared plus 2 times 19 is 38 times y. So 2 times 19 times y is 38y. And also y plus 36 squared. Y plus 36 squared equals to y squared plus 36 squared. 36 squared equals to 1296 plus 2 times y is 2y. 2y times 36 is 72y. So total we found out that 2809 equals to 361 plus y squared plus 38y plus y squared plus 1296 plus 72y. So 2809 equals to, here we have y squared plus y squared is 2y squared. Here 1296 plus 361 equals to 1657. And finally we have 72y plus 38y equals to 110y. So total we found out that 2809 equals to 2y squared plus 1657 plus 110y. So here we subtract 2809 from this equation. So in this side of the equation we left with nothing, that is to say 0, while on the other side of the equation we have 2y squared plus 110y and we have 1657 plus 2809 equals to minus 1152. So today we shall do that 0 equals to 2y squared plus 110y minus 1152. So 2y squared plus 110y minus 1152 equals to 0. I just copied this equation here. So here we divide this equation by 2. And we get that 2y squared over 2 is y squared. Under 10y over 2 is 55y. And minus 1152 over 2 is minus 576 equals to 0 over 2 is 0. This is a quadratic equation, and the general formula for a quadratic equation is as follows: ax squared plus bx plus c equals to 0. This is the general formula for a quadratic equation. A, B, and C are the coefficients of the quadratic equation. And x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus the square root of b squared plus 4 times a times c over 2a. In our specific quadratic equation, this is say y squared plus 55y plus 576 equals to 0. Y squared plus 55y plus 576 equals to 0. The variable that we are looking for is y. So here x equals to y. The coefficient a equals to 1. The coefficient b equals to 55. and the coefficient c equals to minus 576. So here we have all the data that is needed in order to find out the value of y. Just have to put the data inside this general formula for x. In this way we find out the value of the values of y, because y might have two solutions. So we do it now and get that here x equals to y, so we solve x by y. And is equals to minus b. B is 55, therefore minus b is minus 55. Plus minus the square root of b squared. B is 55, therefore b squared is 55 squared. It's actually 3025. Minus 4 times a times c. This is minus 4 times a. A is 1, so minus 4 times 1 is minus 4 times c. C is minus 576, so minus 4 times minus 576 is equal to 2304. So this plus 2304. So inside the root we have 3025 plus 3025 plus 2304 divided by 2a. A is 1, therefore 2a is 2 times 1, that is 2. The total is found out that y equals to minus 55. Y equals to minus 55 plus minus the square root of 3025 plus 2301 plus 2304. 3025 plus 2304 is equal to 5329 divided by 2. So today we found out that y equals to minus 55 plus minus, and the square root of 5329 is 73 over 2. So if we found out that y equals to minus 55 plus minus 73 over 2. Y is the length of this short line segment BL. So y is the length, it must be a positive number, so we take into account only the positive solution for y. And the positive solution for y is as follows. Y equals to minus 55 plus 73 over 2. Minus 55 plus 73 is 18. 18 over 2 is 9. So then we found out that y equals to 9 units in its length. We only found out that x equals to y plus 2. So x equals to y, that is 9 plus 2. 9 plus 2 is 11. So today we found out that x equals to 11 and y equals to 9. Our first task, this question is to find out the area of this square ABCD. So what is the area of square ABCD? The area of square ABCD equals to AB squared. So the left of one side squared. So this is AB squared. AB in total equals to 34 plus x. Therefore, AB squared must be equal to 34 plus x squared. X is 11, so 34 plus x is 34 plus 11 squared. 34 plus 11 is 45, so it is 45 squared. 45 squared is equal to 2025 square inches inside. So in total, we found that the area of square ABCD, those two sides of the equation are equal to each other. The area of square ABCD is equal to 2025 square units in its size. And again, if you found out that the area that we are looking for in this question, that is the area of this square ABCD, is equal to 2025 square units in its size. So we finish to answer the first part of this question. The first part of the second question. The second part of the second question is to find out the length of this tangent PQ. So what is the length of tangent PQ? But again, the second part of this question is to find out the length of tangent PQ. What is the length of tangent PQ? First of all, we focus on this right triangle DBO. On this right triangle DBO, we define this angle BDO as alpha. So in this green right triangle OBD, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. This is tangent PQ, that is tangent to this quarter circle at point K. dk is the radius of this quarter circle. The radius dk is equal to 36. The radius dk is known to point k, that is the point of tendency of tangent PQ with this cotangent. Whenever you have a radius that is known to the point of tendency, then tangent PQ will be perpendicular to the radius KD. If PQ is perpendicular to KD, it means that this angle equals to 90 degrees inside. And this angle also equals to 90 degrees inside according to rule 1. So in this grid, triangle DKQ, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha. Well, because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees, that is the sum of the angles in any triangle. Therefore this first angle must be equal to 90 degrees minus alpha. In the next step, we will do a construction, that is to say, from point P, we will do perpendicular on BD. Again, from point P, we will do perpendicular on BD. Carefully, this angle equals to 90 degrees in size, and this angle also equals to 90 degrees in size according to our construction. We define the touching point of the perpendicular from point P. We define the touching point of the perpendicular from point P and BD. This point is point T. When doing this construction, we're going to do the small quadrilateral PT DC. Inside this small quadrilateral PTDC, those two angles are both right angles because of the fact that there are two angles of the square ABCD. So this is the right angle, and this is the right angle. This angle equals to 90 degrees inside according to our construction. So in total inside the small quadrilateral PTDC we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth angle, the total must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees, and therefore this fourth angle must be equal to 90 degrees in size. So inside the small quadrilateral PTDK we have 4 right angles. Therefore, we relate to quadrilateral PTDK is a rectangle. So it is now quadrilateral PTDC is quadrilateral PTDC is a rectangle because it has 4 right angles. What is the length of AB? AB in total equals to 34 plus x. So x equals to 11. So 34 plus 11 is 45. So AB equals to 45. Likewise, CD must be also equal to 45 because of the fact that all the sides of any square are equal to each other. CD equals to 45. Likewise, side BD of this square ABCD must be also equal to 45, of course. But you also know that the opposite sides of a rectangle are equal to each other. So in this small rectangle PTDC, side CD must be equal to the opposite side PT. But CD is 45, therefore the opposite side PT must be also equal to 45 units in its length. So inside this right triangle QP, inside this right triangle QPT, this angle equals to 90 degrees, this angle equals to 90 degrees minus alpha, and therefore this first angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, that 90 degrees plus 90 degrees is equal to 180 degrees, that is the sum of the angles in any triangle. Therefore, this first rectangle must be equal to alpha. So in the next step, we will prove that this is the right triangle QPT. This right triangle QPT can go into this right triangle OBD according to angle side angle rule. Okay, again we prove that the right triangle OBD can go into this right triangle QPT according to angle side angle rule. Actually, triangle QPT can go into the right triangle OBD according to angle side angle rule. So it is done. So we have to prove that the right triangle OBD can point to the right triangle QPT according to angle side angle rule. So once again, right triangle OBD can point to this right triangle QPT. First of all, those two angles are both equal to alpha and therefore they are equal to each other. This is angle BDO in the green triangle BDO. This is equal to this angle, this is angle QPT. In the right triangle PQT. Okay, again, we should know that angle BDO in the green triangle equals to angle QPT in triangle QPT. They are both equal to alpha and therefore they are equal to each other. In addition, this is side BD of the green triangle OBD. And it is equal to this side PT of the green triangle QPT. Okay, again, we should know that side BD of the green triangle equals to side PT of triangle QPT. They are both equal to 45, and therefore they are equal to each other. Yeah. BD equals to 45 and PT also equals to 45. And finally, those two angles are both equal to 90 degrees minus alpha, and therefore they are equal to each other. So here this is angle BOD. The green triangle OBD. And it is equal to this angle, this is angle PQT. In the right triangle PQT. Quindi again, if you want to in total that angle BOD, the green triangle equals to angle PQT, triangle PQT. They are both equal to 90 degrees minus alpha, and therefore they are equal to each other. So in total, if you want to know that the green triangle BOD can point, this is the same can point to the right triangle PQT. According to angle side angle rule. That is to say, we should found out that those two angles, but before that we should have another thing to prove. Those two angles are both equal to 90 degrees and therefore they are equal to each other. So this is angle OBD. Again, angle OBD. And it is equal to this angle, the actual angle QTP. And the right triangle QPT. They are both equal to 90 degrees and therefore they are equal to each other. So today we found out that the right triangle OBD can go into this right triangle QPT according to angle side angle rule. That is to say, we should prove that those two angles and the side that is included between those two angles, that is side BD on this right triangle POD, corresponding equal to those two angles and the side that is included between those two angles, that is actually side PT, this right triangle QPT. Therefore those two right triangles can go into each other according to angle side angle rule. Again, we have those two angles and the side that is included between those two angles in this right triangle corresponding equal to those two angles and the side that is included between those two angles, this right triangle QPT. Therefore those two right triangles can go into each other according to angle side angle rule. Okay, from the fact that the right triangle OBD can go into this right triangle QPT, we derive that their corresponding sides must be equal to each other in their lengths. According to the rule that said that corresponding sides and congruent triangles are equal to each other. The triangle OBD can go into the right triangle QPT, therefore the corresponding sides must be also equal to each other in their lengths. That is to say, OD equals to QP. Again, OD equals to QP. OD equals to QP. Repeat again, OD equals to QP according to the rule that corresponding sides and congruent triangles are equal to each other. Those two right triangles can go to each other, therefore their corresponding sides must be also equal to each other in their lengths. Why OD is the corresponding side of QP? Because of the fact that OD is the opponent of this right triangle OBD. Likewise, QP is the opponent of this right triangle QPT. Therefore, OD is the corresponding side of QP. But we already found out that OD equals to 53. So I can write here that OD equals to 53. And from this equation, 53 equals to OD equals to QP. We derive that QP must be also equal to 53 units in its length. And again, we should know that tangent QP equals to 53 units in its length. And we already found out that the area of the square ABCD is equal to 2025 square units in its size. So finish to answer the second question. The next step, the next step, that is to say, I'll repeat of the solution of the first question and then I'll repeat of the solution of this second question. In the first question, our task is to find out the length of side AB. So we can define this the height of this right triangle ABC. So we have to find out the length of side AB. This equals to H. So in the drawing, we have a circle that is described by this right triangle, left triangle ABC. BC equals to 40. The radius of this circle equals to 4 units in its length. Again, our test is to find out the length of side AB. So if the base is BC, then the height is AB. So we have to find out the height AB of this right triangle, triangle ABC. So first of all, we define the relevant points of this question with letters. We define the center of this circle, this point as point O. We define the point of tendency of tangent AB with this circle, this point as point D. We define the point of tendency of tangent BC with this circle, this point as point D. And finally, we define the point of tendency of tangent C with this circle, this point as point F. In the next step, we join points O and D together, O and E together by side line. Point O is the center of this circle, point E is the point of the circle itself, therefore O is the radius of the circle, that is equals to 4. The radius of E is equals to 4, the radius of E is drawn to point E, that is the point of tendency of tangent BC with this circle. Whenever a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius EO. If BC is perpendicular to EO, it means this circle equals to 90 degrees, and this circle also equals to 90 degrees, according to 1. Likewise, we join points O and D together by side line. OD is of course the radius of this circle equals to 4. The radius of D is equals to 4. The radius of D is drawn to point D, that is the point of tendency of tangent AB with this circle. Whenever your radius is drawn to the point of tendency, then tangent AB will be perpendicular to the radius DO. If AB is perpendicular to DO, it means that this circle equals to 90 degrees and this circle also equals to 90 degrees according to the sum all 1. So in total, inside the small quadrangle BOEB, we have 1, 2, 3 rectangles. The sum of 3 rectangles is 270 degrees, so 270 degrees plus the size of this fourth circle, in total must be equal to 360 degrees according to the rule that said that the sum of the areas in any quadrangle is equal to 360 degrees. Therefore, this fourth circle must be equal to 90 degrees in its size. So inside the small quadrangle DOEB, we have 4 rectangles. Therefore, we can relate to quadrangle DOEB is a rectangle. But you also know that the opposite sides of a rectangle are equal to each other. So inside the small rectangle DOEB, side DO must be equal to the opposite side BE. But DO is 4, therefore the opposite side BE must be also equal to 4 units in its length. Likewise, according to the sum rule, the same rectangle DOEB, side OE must be equal to the opposite side DB. But OE is 4, therefore the opposite side DB must be also equal to 4 units in its length. So in total, we found out that quadrangle DOEB is not a rectangle but a square because of the fact that all of its sides are equal to each other. Each side equals to 4. What is the length of this piece in segment EC? EC equals to BC minus BE. EC equals to BC minus BE. So EC in total equals to BC, that is 40, minus BE, that is 4. So in total EC equals to 40 minus 4, that is 36. EC equals to 36 units in its length. The next step, we apply the rule 2 in our drawing, and take rule 2. Don't need to rule 2. The lengths of two tangents from a common start point to a circle are equal. So the drawing, we have a circle, this is a common start point P. From this common start point P, we have two tangents to this circle, tangent BA, tangent PA, and tangent PB. And according to this rule 2, they are equal to each other. That is to say, PA equals to PB. So we can actually apply rule 2 in our drawing. Therefore, in our drawing, on this common start point C, we have two tangents to this circle, tangent CE and tangent CF. And according to rule 2, they are equal to each other. That is to say, CE equals to CF. But C is 36, therefore CF must be also equal to 36 units in its length. Likewise, we focus this common start point A. From this common start point A, we have two tangents to this circle, tangent AD and tangent AF. And according to rule 2, they are equal to each other. That is to say, AD equals to AF. So if we define the length of AD as x, then AF must correspond to x because they are equal to each other according to all two. The next step we find the quadratic theorem of this big right triangle ABC. According to the quadratic theorem, in any right triangle, the square of the opposite equals to the sum of the squares of the perpendiculars. So in this right triangle ABC, it means that AC squared, that is the square of the opposite, must equal to AB squared plus BC squared. Repeat again. According to the quadratic theorem in this big right triangle ABC, AC squared, that is the square of the opposite, must equal to AB squared plus BC squared. AC equals to x plus 36, therefore AC squared is x plus 36 squared, and it equals to AB squared. AB in total equals to x plus 4, therefore AB squared is x plus 4 squared, plus BC squared. BC in total equals to 40, therefore BC squared is 40 squared, that is 1600. So in total we found out that x plus 36 squared equals to x plus 4 squared plus 1600. Here we open the brackets on both sides of this equation and find out that x plus 36 squared equals to x squared plus 36 squared, that is 1296, plus 2 times x times 36, that is 72x, equals to x plus 4 squared. X plus 4 squared equals to x squared plus 4 squared, that is 16, plus 2 times x times 4, that is 8x, plus 1600. Go with 1600 from here to here. Here we have x4 on both sides of this equation, for x squared we cancel, so we cancel x squared, in this side of the equation we have only 1296 plus 72x, but on the other side of this equation we left with 16 plus 1600 is 1616 plus 8x. So today we found out that 1296 plus 72x equals to 1616 plus 8x. Here we subtracted x from this equation. So here at x we get cancelled, we left only with 1616, while on the other side of the equation we have 1296 and 72x minus 8x is 64x. So total we found out that 1296 equals to 64x. 1296 plus 64x equals to 1616. Here we subtracted 1296 from this equation, so 1296 we get cancelled and left only in this side of the equation with 64x, while on the other side of the equation we have 1616 minus 1296 equals to 320. So in total we found out that 64x equals to 320. Here we divided this equation by 64, found out here that 64x over 64 is x, and it equals to 320 over 64 is 5. So in total we actually found out that x equals to 5. Our test was to find out the length of side AB. AB in total equals to AD plus DB. And again, AB in total equals to AD plus DB. AD is x, DB is 4. Again, AD is x, DB is 4. So in total, AB equals to x plus 4. X is 5, so x plus 4 is 5 plus 4. 5 plus 4 is 9. So in total, we found out that the right edge of this triangle ABC, that's equal to AB, is equal to 9 units in its length. So we finish to repeat on the first solution of the first question. In the next step, repeat on the solution of the second question. In the second question, we have to find out the area of this square ABCD, and also have to find out the length of this tangent QP. So in the drawing, we have a quarter circle and a semicircle that touch each other externally at this point. And we have also square ABCD, that square ABCD, inside square ABCD we have the quarter circle and the semicircle. And again, our test was to find out the area of this square, and we also have to find out the length of this tangent QP. So first of all, we define the relevant point of this question with letters. we define the center of this semicircle, this point is point O. It gives us the equation that the radius of this semicircle equals to 17. So OA equals to OZ equals to 17. We define the length of this short line segment B as X. We define this point as L. So we define the length of this short line segment BL as Y. LD is the radius of this contact segment, and it equals to 46 units in itself according to what is given in the question. The first task is to find out the area of this square ABCD. So what is the area of square ABCD? Actually, we know that the area of any square equals to the length of one side squared. So it is AB squared. The area of square ABCD equals to AB squared. AB is 17 plus 17 is 34 plus X. So AB is 34 plus X. Therefore, AB squared must be equal to 34 plus X squared. So according to the first method of calculation, the area of square ABCD, that is the area that we're looking for in this question, is equal to 34 plus X squared. The area of the square ABCD equals to also BD squared. So according to the second method of calculation, the area of the same square ABCD equals to BD squared. BD in total equals to y plus 36, therefore b square equals to y plus 36 squared. So the area of square ABCD equals to bd squared is actually y plus 36 squared. So according to the second method of calculation, the area of the same square ABCD equals to y plus 36 squared. So we have two different equations for the area of the same square ABCD, equation 1 and equation 2. Therefore, we can do the equation 3 that says that the area of square ABCD according to the first method of calculation must be equal to the area of the same square ABCD according to the second method of calculation. Very simple equation. The area of square ABCD according to the first method of calculation equals to 34 plus X squared. It must be equal to the area of the same square ABCD according to the second method of calculation. That equals to y plus 36 squared. So if you know that according to equation 3, 34 plus X squared equals to y plus 36 squared. Here we took all out of this equation. So the root cancels the square, you left only with 34 plus X in this side of the equation. Likewise, here the root cancels the square, and we left only with y plus 36. So in total, if you found out that 34 plus X equals to y plus 36. Here we subtract the 34 from the equation, so here 34 will get cancelled, we left only with X, while on the other side of the equation, 36 plus 34 is 2. So in total, in this side of the equation we have y plus 2. So in total, we found out that x equals to y plus 2. Here we can implement rule 10 in our drawing. Because of the fact that the semicircle touches the quarter circle external at point K, you can implement here rule 10. So I repeat quickly on rule 10. According to rule 10, if two circles touch each other externally, then the side line that connects the centers together passes through their touching point. In the drawing, we have those two circles that touch each other externally at point P. The center of this circle is here at point O. The center of this circle is here at point M. The side line that connects the centers together is, of course, the side line OM. According to this rule 10, the side line OM must pass through their touching point, that is point P. Again, the side line OM must pass through point P, that is their touching point. Or OPM is one side line. Again, OPM is one side line according to this rule 10. If OPM is one side line, it means that OM in total must be equal to OP plus PM. So we can actually implement rule 10 in our drawing. Because we have an external between the semicircle and the quarter circle at point K. The center of this semicircle is here at point O. The center of this quarter circle is here at point D. The side line that connects the centers together is, of course, the side line OD. According to rule 10, the side line OD must pass for point K, that is their touching point. Again, the side line OD must pass for their touching point, that is point K. Or OKD is one side line. Again, OKD is one side line. So if OKD is one side line, so join points OD together one side line, so the side line OD must pass for point K. This is why it is to see that the side line OD indeed passes for point K. This is the tangent point. And OD total must be equal to OK plus KD. So OD equals to OK. OK is the radius of this semicircle, is equals to 17, plus KD. KD is the radius of this quarter circle, is equals to 36. So total OD equals to 17 plus 36, that is 53. OD equals to 53, everything is left. In the next step, we implement the Badal's theorem on this right triangle OBD. According to the Badal's theorem, in a right triangle, the square of the opposite equals to the sum of the sides of the perpendiculars. That is to say, this again right triangle OBD, OD squared, that is the sum of the opposite, equals to OB squared plus BD squared. Repeat again, this again right triangle OBD, according to the Badal's theorem, OD squared, that is the square of the opposite, equals to OB squared plus BD squared. OD equals to 53, therefore OD squared is 53 squared, that is 2809, and it is equals to OB squared. OB is 17 plus x, therefore OB squared is 17 plus x squared, plus BD squared. BD in totality is y plus 36, therefore BD squared is y plus 36 squared. So in total, we shall know that 2809 equals to 17 plus x squared plus y plus 36 squared. So we open the brackets on this side of this equation. Finally found out that 2809 equals to, but before that, we know that x, we found out that x equals to y plus 2. Therefore, we can substitute x here by y plus 2. So 17 plus x is 17 plus y plus 2. 17 plus 2 is 19, so in total this expression equals to 19 plus y squared. So in total we found out that 2809 equals to 19 plus y squared plus y plus 36y plus y plus 36 squared. So open the brackets on both sides of this equation, and finally found out that 2809 equals to 19 plus y squared. 19 plus y squared equals to 19 squared, that is 461, plus y squared, plus 2 times 19 is 38 times y. 38y, plus y plus 36 square. Y plus 36 square equals to y square, plus 36 square, that is 1296, plus 2 times y times 36, that is 72y. So here we have, in this of the equation, we have 2809. On the other side of the equation, we have y squared plus y squared is 2y squared. 361 plus 1657. 361 plus 1296 equals to 1657. And 38y plus 72y equals to 110y. So total if you want that 2809 equals to 2y squared plus 1657 plus 110y. Here we subtract 2809 from this equation, so here 2809 will get cancelled and we have to leave 0 in this side of the equation, while on the other side of the equation we have 2y squared, and we have 1657 minus 2809 equals to minus 1152, and we also plus 110y. So in total, if you found out that 0 equals to 2y squared plus 110y minus 1152. So here we divide this equation by 2, if I found out that, again, in total, if you found out that 2y squared plus 110y minus 1152 equals to 0. So here we divided this equation by 2, and if I found out that 2y squared over 2 is y squared, plus 110y over 2 is 55y, and minus 1152 over 2 is minus 560, minus 576, and it is equals to 0 over 2. 0 over 2 is 0. So in total, if you found out that y squared plus 55y minus 576 equals to 0. So this is a quadratic equation. And the general formula for a quadratic equation is as follows: ax squared plus bx plus c equals to 0. This general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus 1 square of b squared minus 4 times a times c over 2a. Now a specific quadratic equation, that is to say y squared plus 55y minus 576 equals to 0. Now a specific quadratic equation, the variable that we are looking for is y. So x equals to y, so this is the variable that we are looking for. The coefficient a equals to 1, the coefficient b equals to 55, and the coefficient c equals to minus 576. So we have all the data that is needed in order to find out the value of y. We just have to put the data of our specific quadratic equation inside this general formula for x, and this way we find out the value of the values of y, because y might have two solutions. So we did it, and we found out that so x equals to y, so we substitute x by y, and x equals to minus b. B equals to 55, therefore b squared equals to minus 55, and therefore minus b equals to minus 55, plus minus the square root of b squared. B is 55, therefore b squared is 3025, minus 4 times a times c. That is minus 4 times a. A is 1, so minus 4 times 1 is minus 4 times c. C is minus 576, so minus 4 times minus 100, minus 4 times minus 576 equals to 2304. So total inside the root we have 3025 plus 2304 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So total we found out that y equals to minus 55 plus minus 3025 plus 2304 equals to 5329 divided by 2. The square root of 5329 is 73. So total we found out that y equals to minus 55 plus minus 73 over 2. Because of the fact that y is the length of 9BL, y is the length must be a positive number, so here we take only the positive solution for y. The positive solution for y is as follows: y equals to minus 55 plus 73 over 2. Minus 55 plus 73, minus 55 plus 73 is 18, 18 over 2 is 9. So if you found out in total that y equals to 9, we already found out that x equals to y plus 2. So x equals to y, that is 9 plus 2. 9 plus 2 is 11. So in total, if you found out that y equals to 9 and x equals to 11. So the first test is to find out the area of this square ABCD. What is the area of this square ABCD? The area of square ABCD equals to the length of one side squared. That is to say it is AB squared. So the area of square ABCD equals to the length of one side squared. That is to say it is AB squared. AB in total equals to 34 plus x, therefore AB squared is 34 plus x squared. So AB squared equals to 34 plus x squared. But x is 11, so 34 plus x is 34 plus 11 squared. 34 plus 11 is 45, so it is 45 squared. 45 squared is 225. So total, if you found out that the area of square ABCD equals to 2025 squares in size. So finish to answer the first part of this question. The next step, answer the second part of this question. This is to say we found out the length of this tangent QP. What is the length of tangent QP? First of all, we find this angle BDO as alpha. So indeed, again, triangle OBD, this angle equals to 90 degrees, this angle equals to alpha, therefore this first angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees, that is the sum of the angles in any triangle. Tangent QP is tangent to the quarter-circle at point K. The radius dk of this quarter-circle, the radius dk is drawn to point K, that is the point of tendency of tangent PQ with this circle, with this quarter-circle. And now you have radius that is drawn to the point of tendency, then tangent PQ will be perpendicular to the radius KD. If PQ is perpendicular to KD, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to all one. So inside the small green triangle KQD, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha. 1 equals 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees, that is the sum of the angles in any triangle. In the next step, we did the construction, that is to say from point P, we do perpendicular on BD. From point B, we do perpendicular on BD. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular curve from point P and BD, this point is point T. When did this construction, we added the small quadrilateral PT-DC. Inside the small quadrilateral PT-DC, those two angles are both right angles, but now two angles inside square ABCD, therefore it must be equal to 90 degrees in their sides. This angle equals to 90 degrees according to our construction. So in total, inside the small quadrilateral PT-DC, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this 4 angle, in total must be equal to 360 degrees, according to the rule that said that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this 4 angle must be equal to 90 degrees in its size. So inside the small quadrilateral PT-DC, we have 4 angles, therefore we let to quadrilateral PT-DC is a right angle. AB equals to 34 plus x. X is 11, so AB equals to 34 plus 11. 34 plus 11 is 45. Therefore, CD must be also equal to 45. BD must be also equal to 45 because of the fact that all the sides of n square are equal to each other in their lengths. So BD equals to 45 and CD also equals to 45. But you also know that the opposite sides of a rectangle are equal to each other. So inside the small rectangle, PDC side, the CD must be equal to the opposite side PT. But CD is 45, therefore PT must be also equal to 45 minutes in its length. So in the next step, we prove that the green rectangle OBD can go into this rectangle PQT according to angle side angle rule. But before that, this rectangle QPT, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to alpha. 1 goes 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of degrees in any triangle. Therefore this first angle must be equal to alpha. So in the next step, we prove that the right green triangle OBD can go into this right triangle QPT according to angle side angle rule. So right green triangle OBD can go into this right triangle QPT. First of all, those two angles are both equal to 90 degrees and therefore they are equal to each other. In addition, BD equals to PT equals to 45. And finally, those two angles are both equal to alpha and therefore they are equal to each other. Therefore, the right triangle BD can go into the right triangle QPT according to angle side angle rule. And again, for the found out that the again right triangle BOD can go in, this is the side of can go in, to the right triangle QPT according to angle side angle rule. That is to say that we prove that those two angles and the side is included between those two angles in this right triangle OBD correspond equal to those two angles and the side is included between those two angles in this right triangle QPT. Therefore, those two right triangles can go into each other according to angle side angle rule. Repeat again. We have those two angles and the side is included between those two angles in this green triangle correspond equal to those two angles. The side is included between those two angles in this right triangle QPT. Therefore, those two right triangles can go into each other according to angle side angle rule. From the fact that they can go into each other, we will derive that their corresponding sides must also equal to each other in their lengths. That is to say, OD equals to QP. OD equals to QP, according to the rule that correspond in size and congruent triangles are equal to each other. Those two triangles congruent to each other, therefore their corresponding sides must also equal to each other in their lengths. All these the opponents of the green triangle, therefore the corresponding side of the opponents OD must be equal to the opponents QP for the right triangle QPT. Therefore, all this is the corresponding side of QP, therefore OD equals to QP. But OD is 53. So can I say that OD is 53? And for this equation, 53 equals to OD equals to QP. We derive that QP must be also equal to 53 units in itself. So in total, we found out that the length of tangent QP is 53 units, and the area of this square ABCD is equal to 2025 units in its size. Okay, thank you very much.